Okay, so in this part, we will try to understand how to write down pair of tangents drawn from external point. Means we have already studied if the point is on the curve, then we will have one tangent and you have to write down equation of that tangent. Now this time what will happen? Your point will be staying outside the curve and you have to write down equation of tangent. So you know that if point is outside, then we will have two tangents. Okay, so you have to write down equation of two tangents. So this concept we have studied in circle, parabola, and right now we will study in ellipse. It is same everywhere, that is S1 equals t square. Okay, so who is S? S is equation of curve. Who is S1? S1 is point satisfaction. Okay, means you will have a curve, you will have this point P, you have to satisfy the point on the curve. The number which you will get, you have to write it here. And then T is transformation. Okay, so T is transformation. So how we will take transformation? You know that you have handled x square with x1. Suppose this P is x1 y1. Now who is y square? Y1. Okay, now your x will be replaced by x plus x1 by 2. Y will be replaced by y plus y1 by 2, and then we will have xy. Xy will be replaced by x y1 plus x1 y by 2. Constant element will stay as c. Okay, so this is how we will write combined equation of pair of tangents. Okay, so you will get this one. If you want independent equation, go with factorization. You have studied this concept in straight line. You can factorize those two uh, curves. Okay, now next is chord of contact. Now try to understand what is chord of contact. Suppose that you will have a curve, you will have a point outside the curve. Okay, so from here you can drop two tangents, you know. Suppose that your tangent intersect ellipse at point A and point B. Okay, so if it will touch at point A and point B, this is representing chord of contact. Okay, this is representing chord of contact. So how we will write? We will write t equals to 0 and things is done. Okay, now we have to write down chord, equation of chord if midpoint is given. Means you will have a curve. Suppose that we have this curve. Suppose that we have this curve. Okay, and we have a point inside the curve, this. Okay, so from this point we can drop infinite chords. Okay, infinite chords you can drop. So among these chords there will be one chord which will be bisected at the given point. Okay, so this chord I am talking about. So this equation we have to write, equation of chord if midpoint is given. So how we will do that? We will write t equals s1 and things are done. I hope this concept is clear because you have studied the same concept multiple times, but for the sake of completion I am going through it one by one. Okay, I hope the idea is clear.